Hello guys, good evening. Am I audible? Those who are watching this session, please respond. Am I audible guys? Yeah guys, so let's start today's session. So guys, we are solving GATE Aerospace Engineering PYQs, and in PYQs, today we will take up GATE 2012 paper for aerospace engineering, and in that paper we'll be discussing aircraft structures related questions. So today's session is for GATE 2012 for aerospace engineering aircraft structures part. Okay, guys. So in aircraft structures, we have two subjects. One is SOM, and second is thin walled structures part. Okay. So guys, in 2012 paper, they asked very less number of questions from thin walled from aircraft structures part. And guys, even most of the questions are theoretical question except one numerical. So here weightage is very less if you take GATE 2012 paper. Usually weightage of aircraft structures part in GATE Aerospace Engineering is like close to 17 to 20 marks. Okay, but in this paper it is only 11 marks. So read first question what it says, guys. The governing equation for static transverse deflection of a beam under an uniformly distributed load according to Euler-Bernoulli beam theory is. So guys, as per Euler-Bernoulli beam theory, if you take a section of beam and it is subjected to some UDL Q. So what is moment curvature relation? So M is given by what? EI d square, and if your vertical deflection is V, so it is M equal to EI d square V by dx square. Now guys, we know from equilibrium, the shear force is given by dm by dx, and your this applied UDL is given by minus of dv by dx. So from here your q will be minus d square m by minus d square m by dx square, and we already know what is m. It is given by ei d square v by dx square. So when you substitute, you will get minus ei d power 4 v, which is what? Deflection in vertical direction, dx power 4. So from here, if you write your differential equation, governing differential equation for beam, it will be what? It will be d power 4 v, which will be function of x, dx power 4 equal to minus q upon ei. So this is what? It is a fourth order ordinary differential equation. Also, it's a linear equation and it is non-homogeneous equation. Why non-homogeneous equation? Because this side is non-zero. Okay, and it's a linear differential equation. So if you look into option, the correct option is what? It's a fourth order linear non-homogeneous ordinary differential equation. So B is the answer. B is the answer. Now guys, further you guys can look into property of differential equation and can find out which is linear, which is non-linear ordinary differential equation, which is homogeneous and which is non-homogeneous ordinary differential equation. So B is the correct answer for this question. Let's read next question what it says. The Poisson's ratio nu of most aircraft grade metallic alloys has values in the range. So guys, most of the aircraft grade metallic alloys are what? Aluminum alloys. Okay, and usually for aluminum alloys or titanium alloys, okay, both are ductile. Okay, and nu is approximately zero point 0.3. Now you guys see, among all these four options, where zero point 0.3 lies, in which option zero point 0.3 lies, guys? In first option it is not lying. If you see second option, also zero point 0.3 is not lying. In option C, you can see it is between 0.2 to 0.4. So 0.3 is lying. So C can be correct. And if you look option D, again 0.3 is out of range. So D is not correct. So correct answer is C. But guys, in general, what is the range for Poisson's ratio for any material? So for any material, the minimum value of Poisson's ratio can be -1 and maximum value can be 0.5. Okay, so nu has to be equal or lesser than 0.5 or greater than -1. So these values are decided by what? Which value? By G and K. Okay, so you guys know, right? What is G? G equal to E upon 1 minus 2 nu, if I remember correctly. Okay, now guys, if if nu greater than 0.5, what will happen? G become negative, which is not possible. So what is the limiting value for nu? Nu should be lesser than equal to 0.5. Now what is the K? So K is given by what? E upon 3 into 1 plus nu. Now guys, if nu is lesser than -1, what will happen? Your K will become negative. So which is not? Think, am I saying correctly? I think G is it correct? What is the range for E and just a moment, guys. I think I'm missing here. E is given by, just a moment, guys. Just a moment. Quickly, I will just verify whatever I have written is correct or not. Long back, I have not seen that. Just a moment, guys. Going wrongly. Yeah, perfect. Okay, so guys, basically here I have written wrong. Okay, here it is. It is like this. So your K value is given by what? E upon 3 into 1 minus 2 nu, and your G value, your G value is given as E upon 2 into 1 plus mu. It is like this, guys. Okay. Sorry, guys. Now, guys, here, if your nu is greater than 0.5, your K will become infinity. Your K will become, sorry, K will become negative, which is not possible. Okay. So, nu should be lesser than or equal to 0.5. When nu equal to 0.5, what happens? Your K become infinity. That means that time your material is known as perfectly incompressible. Okay, incompressible. Now guys, when nu is lesser than -1, your g your g is negative. Okay, your g is negative, so g can't be negative, so nu should be always nu should be always greater than -1. Okay, so these are the values for nu. So nu should be greater than -1 and less than equal to 0.5. Okay, clear? So let's move to, anyone have any doubt, guys? Hopefully no doubt, because here I was missing K. So K is known as what? Bulk modulus of elasticity, and G is what? Modulus of rigidity, guys. Okay, let's move to next question. What it says: in a semi-monocoque construction of an aircraft wing, the skin and spar webs are primary carries of. So in semi-monocoque structure, guys, skin and spar web. So skin carries what? Shear stresses usually, guys. Okay. So shear stresses can be developed due to aerodynamics loads, or it can be due to moment components. So D is the answer. So guys, if you see semi-monocoque structure of like wing structure, so you can see, guys, this is what the shape of wing, and you can see this is how spar positions. Suppose in this wing there are two spars, one is the front and back spar. So you can see this is known as spar cap, which primarily carries what? Bending, and this is what? Spar web. So this skin and spar web carries what? Shear stresses, and those shear stresses are developed either due to aerodynamics loads, aerodynamic forces, or due to moments. Okay, due to moments. So D is the correct answer. Okay, aerodynamics forces and moment components. Okay, so let's see the next question, what it says. Yeah, so again, this is airy stress function question, and in last two paper also we saw there was a question from airy stress function. So read the question, what it says. The airy stress function phi equal to alpha x square plus beta xy plus gamma y square for a thin square panel of size L by L automatically satisfies compatibility if the panel is subjected to uniform tensile stress sigma naught on all four edges. The traction boundary conditions are satisfied by. So guys, here there is a thin panel, square panel of length L by L. Now this is subjected to across all four edges tensile stress of magnitude sigma naught. So that means in this case, if you take this as xy coordinate, your sigma x here is equal to what? Sigma naught. Your sigma y is also sigma naught. And since it's a biaxial stress system, there is no shear here. Only tensile stresses are acting on all four edges. So tau xy is 0. So from we also know from Airy stress function what? Sigma x is given by what? Dou square phi by dou y square. Sigma y is given by what? Dou square phi by dou x square. And your tau xy is given by what? Minus dou square phi by dou x dou y. Now guys, phi is already given. What is the value of phi is given? It is alpha x square plus beta xy plus gamma y square. Now guys, substitute these five values in these expression. So what you get sigma x when you differentiate this phi with respect to y twice. So you will get 2 gamma, and already sigma x is known as sigma naught. So from here gamma is what? It is sigma naught by 2. Now guys, what about sigma y? When you substitute phi in this and differentiate twice with respect to x, you will be getting sigma y equal to 2 alpha. So it is already known, it is sigma naught. So from here, what your alpha will be coming sigma naught by 2. Now what about tau xy? When you differentiate twice phi with respect to x and y, you will get your tau xy equal to minus beta, and we already know tau xy here it is 0. So from here what is your beta is 0. So what is your alpha beta gamma? Your alpha beta gamma is given by what? Sigma naught by 2 comma 0 comma sigma naught by 2. So which is the correct answer in this case? You look, A is the correct answer. Okay. Alpha is sigma naught by 2, beta is 0, and gamma is sigma naught by 2. So, if you guys have any doubt, be free to ask. If you guys have any doubt. Okay, so let's see next question, guys. So, this is alpha, this is beta, and this is gamma. So, let's see next question. Yeah, what it says: buckling of the fuselage skin can be delayed by. So guys, the first option says increasing internal pressure. So guys, buckling happens usually if you take the buckling of plate. The buckling happens due to compressive stresses. So when you pressurize your skin, tensile stresses will be developed. So your compressive load will get down. That means your buckling strength will increase. So your buckling will be delayed. So A can be the correct answer. Now look, option B, placing stiffeners for the raft. So that will do what? It will increase the panel length. So when panel length will be increased, your buckling strength will go down. Okay, so that means buckling will occur early. It will not be delayed. So B can't be the correct answer. Now read the option C. What said? Reducing skin thickness. So when you reduce skin thickness, your moment of inertia will go down. So that means your buckling strength will go down because your buckling strength is directly proportional to your I value. Okay, so that means C can't be the correct answer. And of course D says what? Placing stiffness further and decreasing internal pressure. So that means D is also not correct, because anyway B option is there in D and also it is opposite to A. So the correct answer is only A is the correct answer. So how the buckling strength can be increased? By putting more number of stiffeners. So the panel length will be decreased. Then increasing internal pressure. Of course, increasing internal pressure will require to increase the thickness. So there will be weight penalty. Now by increasing thickness also buckling strength can be increased. Okay. So the correct answer in this case is A. Let's see next question, and that is last question. So 54 and 55 are linked questions, guys. Okay, common data question. So read the question what it says. A thin walled spherical vessels 1 meter inner diameter and 10 wall thickness is made of a material with sigma yield modulus. Means what? The yield in tension and compression, in both cases it is 500 megapascal. Now guys, question number 54 says what? The internal pressure Py at yield, Py at yield based on the von Mises yield criterion. Von Mises yield criterion. If the pressure, if the vessel is floating in space, is approximately. So guys, here if you take spherical vessel and if you take any stress element on that, you will find your stresses acting in in all the direction. Your normal stress is same. What it means? Your sigma circumferential, which is like hoop stress, okay, is given by what? PD by 40 in case of spherical cell. And in case of spherical cell, all the directions are principal directions. So that means your sigma 1 will be equal to sigma 2 will be equal to sigma C, and which is nothing but PD by 40. How I said all the directions are principal direction? Because this is also sigma C, this is also sigma C, sigma C, sigma C. So now guys, there is no corresponding shear and all the normal stresses are same. So that means all the direction will be principal direction. Okay, PD by 40. Now we know what is sigma 1 minus stress for 2D stress system. It is given by sigma 1 square plus sigma 2 square minus sigma 1 into sigma 2. Now guys, what is this sigma 1 and sigma 2? These are principal stresses. So in case of spherical vessels, sigma 1 minus is always equal to sigma C, because this is nothing but sigma 1 and sigma 2. So what it is? PD by 40. What it is? PD by 40. Okay. Now guys, at yield, when your pressure is acting outward, when pressure is acting outward, okay, so it will fall under tension. So at yield, your sigma y will be equal to sigma 1 minus, and they already mentioned PD by 40. What is the yield? It is equal to 500. So now what is the pressure? It is 500 into 4 into 10 upon what is the diameter, PD by 40. So what is the diameter? I think it is given as 1 meter. So 1000 mm. So from here we find P equal to 20 megapascal. Okay, so at yield your pressure will be equal to 20 megapascal. So option D is correct. Now guys, read the question. Next question, what it says. If the vessel is evacuated, internal pressure is equal to 0 and subjected to external pressure, yielding according to the von Mises yield criterion. Okay. Now guys, what is happening? Instead of in first case, the pressure is internal, means it is outward pressure. Okay. It is outward. So what we saw, if you take any stress element, what you saw, your stresses were tensile nature. Now guys, what happened? The internal pressure is removed and externally the same pressure P is applied. So in this case, what will happen? Your stress element will subject it to same stress but compressive nature. So in this case, your sigma C will be minus PD by 4T. Now in this case also guys, if you find sigma 1 Mises, your sigma 1 Mises will be equal to what? This is sigma 1 and this will be equal to minus PD by 4. Now at yield guys, your sigma 1 Mises and here yielding is under compression will be equal to what? Minus of sigma y. So that means minus PD by 4T is equal to minus of 500. And from here again your pressure which is acting from outside will come as 20 megapascal. Okay, so that means yield will occur at the same pressure. So C is the correct answer. Occurs about the same pressure Py. So C is the correct answer in this case. So I guess I think that's all from today's session. These many questions were only from aircraft structures part. So in GATE 2012, you can see they asked very less number of questions from aircraft structures part. And guys, you can contact us for any support for GATE or PSUs related to aerospace engineering. You can write mail or visit our website. You guys can also subscribe to our YouTube channels for more lectures and can join Telegram for daily quiz and all. And you guys can also follow us on a different social media platform. So if any doubt, guys, be free to ask. Anyone have any doubt? Okay, guys, then thank you for watching for this session.